Welcome everyone. My name is Valentin. As Ines said, I'm a software developer, and yes, we're waiting for the slides. But yeah, today we are going to do something a little different. In an industry obsessed with the future, with the next frameworks, next programming languages, or AI, we are going to look back. We are going to do something similar to what Renaissance architects did by studying and measuring the buildings of ancient Rome. Because they did this to understand the core principles of form, function, durability that made those buildings last for centuries. In that same spirit, we are going to dissect a foundational piece of software that is the very first Git commit created by Linus Torvalds. And by studying this ancient code, we will try to uncover powerful design principles that have made Git the cornerstone of modern software development. So, in summary, it's a story about how clear design, how design quality can lead us to create very powerful tools. But to understand Git, we need to understand its origin story. And it's important to mention that it wasn't born out of a desire for a new toy, but of a critical need for the Linux kernel team, because in 2005 they lost access to BitKeeper, their control version system at that moment, and then they need to find a solution for that. So Linus wrote Git in 10 days, and the first Git commit already had the core ideas that we're still using today. And well, he wrote the code in 10 days, but he was thinking about it for more time, since they realized that they have the problem with BitKeeper. Something to mention here is that he prioritized like the correctness of the program and the core model, and not the UI, and that it should be user-friendly for the rest of the people. Well, at least, not at least, but his approach was like he wanted to solve his problems first, and then if it's useful for the rest of the people, well, this will be great. And here is it. This is the first comment that has started it all. Well, the commit message, I think it's very small from there, but yeah, it says something like the information manager from hell, and it itself gives us a sense of the pragmatic and somehow irreverent philosophy behind Git. Like, he wanted to solve his problem, and he hated the current system control versions that were available at that moment. So the first commit is surprisingly small, just 11 files and under 1,000 of lines of C code. But within this small code base, we can like see the revolutionary ideas that were there from the beginning. From the 11 files, 7 of them are like standalone programs with very clear purpose. Like, we have the initdb file that is in charge to initiate the repository structure. We have the update cache command to manage the staging area of Git. We have the write tree, commit tree commands to create the basic objects, and also the cat file, like a tool to inspect those objects. So it wasn't a single monolithic program. It was more like a toolkit of things. And also, the choice of wrote it in C was also deliberate because performance and portability were very important for the Linux kernel's needs. If you remember only one thing from this talk, let it be this, that Git is not primary version control system. It's only the application of top of it. Git at its heart is a content addressable file system. And this was a completely different approach to solve this kind of problem because in Git, we have that every file that is managed by the repository is saved as an object in the internal database of Git. But in Git, we don't have, for example, we don't save, or Git doesn't save the different chunks of data that are the delta parts of the changes that are made during the process. So this is the most important idea in Git. Like I said, we can think of Git as a big box of objects, and every time we save something, it's become an object in the Git system. And the other interesting part is that the ID that each object gets comes from its content. He uses a hash function to create that. So if two files have the same content, they will get the same ID. And yeah, the content itself make the name of the file. And this is why Git is so good at keeping the work safe, because the data can be corrupted by design. If something changed in the data, the ID or the name of the object will change, and then the program will realize that, will catch that. So yeah, it doesn't store deltas of the changes. It stores snapshots of the content that is modified during the lifetime of the project. And yeah, this is revolutionary, at least at that point, regarding the system control version software that we had. But how does Git build things? So it uses 3 simple building blocks. And if you understand those, you will understand Git much better. Like we have the blobs, the trees, and the commits. And we will take a look at each one right now. First, we have the blob, and the blob is the what, is the content of every file that we have in the repository. It can be text, audio file, image, doesn't matter, because it will be converted in a byte stream, and it will be saved as a byte streams in the database of objects of Git, in that box that everything is an object. On the left side, we have a text representation of the object, where you can see that, like, we have the tag that identifies the object type, in that case, blob. We have a single space to separate this. Then we have the size of the blob data in bytes. This is important because it's a mechanism that he will use to verify that the content has changed or not when they are added to the staging area. And at the end, we have the blob data, that is the streams of bytes. But yeah, no, it's only the content. This is the relevant part. No metadata as when the file was created or something like that. Only the content. And yeah, it will give to this file a special ID based on created with the hash function. And again, if something changed to this file, the identifier will change too. So yeah, basically Git will, if something changes in the file, Git will create a new object. And yeah, this is an important rule in Git because basically he never deletes nothing, only adds new objects when the content of them change. Okay, so the blobs hold what is in your file, but then we need to understand where do the files go. And that's the purpose of the trees. The trees is like a list of all the different paths and their content that has been introduced to Git. So the list on the left, we can see that again we have the tree tag object, like the tag object, and then we have a list of file paths and a pointer to the blob object that represent each of the paths. And yeah, this is the way that Git do the snapshots of the current state, or when you decide to commit something to the repository, it captures the whole thing of the whole files that you have in the repository with a tree. And last, we have the commit. The commit is like the who, when, and why the tree was created. And basically, this is the part that ties everything together. And also, since here we have a pointer to the previous commit or the parent commit, this is what enables Git to create the history, because you can chain the previous states of the repository. What else? Yeah, and of course, I mentioned that this is the place where we add the modern Git message, explaining why these snapshots was taken, or why the changes are made. The other important concept in Git available in this first commit was the index, and it's probably one of the most powerful features in Git, because it gives you a precise control about what goes to a commit and what not. You have you have a very powerful tool to create a clear history of the changes. And yeah, here on the left we can see the structure, what kind of information it holds, it contains. And yeah, we can also think about the staging area or the index as a factory of commits, where we have all the relevant data needed to create the commit. Linus are also Linus also made Linux, and he liked it a lot, the ideas of the Unix world. And we can understand that Git was built with those ideas in mind. Like the main idea to keep the things simple and make small tools around something that do one thing well. Well, Git is it's a great example of this. Like we saw at the beginning, even in the first commit, with very small amount of code, he had this small, clear idea about the data structure, the data model, sorry, and several tools, several standalone programs that do one thing well. So Git was not one big program, it was a small set of tools, and yeah, this is one of the reasons that Git evolved so well, because the tools can be used in different ways to implement different workflows. Linus, actually there is a very good recent interview of him made by GitHub in their YouTube channel. You can see the link at the end of the presentation, where he mentioned that he's still using a very limited amount of all the Git commands that are available, but because that were his needs. But since the basic primitives are so well designed, the rest of the people could arrange them in a ways that allowed implementing different workflows for their current needs. And we can see like the relation between the commands in the original, well, in the first commit, in comparison to the modern Git, that hasn't changed a lot. Well, the naming, yes, a little bit, but probably they still, in their core, they still doing the same thing. And that's amazing for a piece of software of 20 years. Another simple idea that was used was to use the computer's own file system instead of a specialized database, because it's easy to read. Like right now, well, at the beginning too, but today also, we have all the objects saved in the hidden Git directory. At the beginning it was called dir cache, but it's the same idea. Like you have access, you can inspect, read the objects. They are not like they are very transparent to us. We can inspect them, see if something is wrong, fix them. We also can move them to other place. But yeah, this kind of using the universal abstractions, in this case directly the file system, to create the data model and make it transparent was also inspiration from Unix world. So yeah, the first commit doesn't have all the features that we know and love today, but it had something more important. It had the very strong foundation. Like I said before, the idea of the content addressable file system and the small amount of tools that do one thing well was what made Git so elegant, or the design of Git so elegant at the beginning. And that enables Git to scale very well through the time. So basically today, the entire world in software development is using this software. So the next time when you type git commit, you should remember the powerful, you could remember the powerful and simple ideas behind what created Git in the first place 20 years ago. And as a next steps, if this talk got your interest, I will recommend you these two books. The first one talks about the initial version of Git, and there is a super good explanation about well, explanation and analysis of the C code and the algorithms used by Linus to implement Git, and also has instructions how to compile the first commit, because it's possible and it works. It's magic in that sense, because like it's very accessible even for new programmers, because of the amount of code. It's less than 1,000 lines of code, and also because he uses universal abstractions, universal functions implemented long ago, so it's easy to follow, to understand. But I think it's like the work of studying it by yourself is what could give you this kind of sense of, okay, now I got it. I understand how a very powerful software could be created with tools that are accessible for everyone. In the other book, The Art of Unix Programming, well, it goes deeper about the Unix philosophy. That again, today it seems that we are trying to look at the future, trying to find new tools and new ways to solve our problems. But at the same time, I don't know if this is because the industry is too young, but it seems that several years ago, people found similar problems and they found very interesting solutions to deal with them. Here are the references. I don't know if we will share the slides with you. Well, if you want it, you can find me on LinkedIn or Slack, and I could share it with you to have the references. Yeah, and here are the credits. Thank you. Well, I will leave this. So, any questions?
Okay. Hello. Okay. Well, first of all, thank you for your talk. It has been very interesting. And my question is, things like branches, it's something that Linus also had in mind and implemented later, or is something that came later?
Very interesting question. It wasn't there as a feature, like you hadn't a command that create branches, but the building blocks are all already there, because when you have the history of commits, like one commit can point to the parent, then you have the option to create the branches from there. Okay, you can start new commits based on different parents. So the functionality was already there, but not explicitly named as branches. And the merge, again, it was possible to do the merge. Actually, at the beginning, it was made by hand, like you get the two different commits, get the diffs, and you should go there and resolve the conflicts by yourself. Well, not the conflicts, but do the merge. You will have the two versions of the files or the changes. But yeah, having the history of changes already allows you to have branches and merges.
Thank you.
Well, it's a simple. I have a curiosity.
Yeah.
It's a bit of a silly question. Do you know why it's named Git?
Well, there are several explanations about it. Actually, in the README file of the first commit, Linus already gives some explanation, and well, not explanation, but some options what Git could mean. But at the end, it doesn't matter. He say that he's very bad at naming things, and just
Short enough.
Yeah. Well, I haven't forgot to ask if everyone, if someone didn't know Git before that. All of you know Git, right? Okay. Because yeah, it's a little bit late, but if that was the case, I will try to explain what Git is in the first place. Yeah.
Thank you for your talk. Yes, I have a question about diff, Git diff. Initially, did Linux use tool Git, tool diff that that Linux has, or it was another version of diff,
No,
especially for Git?
Sorry for interrupting, but yes, he used the tool that we have in the Unix-based systems, the diff tool, to make the diff files.
Okay, and for me, it was new seeing that every commit stores each full content, full object, full file. How to say? Because it's very expensive to store each file for each commit. What do you think? Good or bad?
Well, let me go. Well, we don't have the slides anymore, but actually, he doesn't. In each commit, he saved the reference to each file. But if the file hasn't changed, the reference is the same. So in that sense, it was very efficient because, like I mentioned before, we had the content addressable system. So if a file doesn't change, we will still have the same ID, and in the next commits, we will save only the reference to that name. So in this sense, I think it was very efficient because the content was saved only once. Of course, it was like when you perform the diffs, you should get the content of the two versions and compare them. And it's hard to get the history of changes of only one file. But yeah, I think if you should evaluate the trade-offs, it was better in that sense because you have a very safe system to write the content, and then something more expensive when you need to perform this kind of consults, like the diffs between different files and so on.
Thank you.
Anyone else?